Hi students, I'm your Komali Mam. In this session, I'm going to teach you P block boron family because it's the exam time and you are worrying about maybe how to read this boron family. That's why in this session, I'm going to teach you boron family, the questions from the boron family. Watch this video up to the end. After that, you feel very easy to solve the questions from the boron family. You get very good grip. Let's begin the session.
കരിങ്കാലിയല്ലേ കൊടുങ്ങല്ലൊരു വാഴണ പെണ്ണാള് കൊടുവാളെടുത്ത് ചുടുതാരികച്ചോരയിൽ നീരാട് കരിങ്കാലിയല്ലേ കൊടുങ്ങല്ലൊരു വാഴണ പെണ്ണാള്.
Which of the following statements are correct? This is not from boron family, this question. It is from overall periodic table. The difference in inner core of elements influences their physical properties. If you see, inner core electrons means, for example, aluminium. Okay, aluminium. What is an electronic configuration of aluminium? 1s2, 2s2, 2p6, 3s2, 3p1. And aluminium next element is gallium. In gallium, what will happen? You know, this is 3s2, 3p1 is the valence shell. Here, 4s2, 4p1 is the valence shell. In other than valence shell, remaining electrons are called as core electrons. In gallium, 3d will be fully filled. Due to the presence of this 3D fully filled, its radius is smaller than the aluminium. Later we will see why, so what will happen. So what I want to say is, other than valence electrons, remaining electrons are called inner core electrons. These inner core electrons are responsible for the physical properties of the molecules, elements. This is correct statement. Next. P block consists of non-metals, metalloids and metals. You can see P block contains non-metals and it contains metalloids. Here, boron is given as a metalloid, but NCERT, class 11 NCERT gives boron is a typical, non-metal. It is having slight metallic character, least metallic character in the top to bottom. Other than boron, remaining all elements are metals. Boron is the least metallic character. That's why few they say it is a metalloid, and NCERT says it is a class 11 NCERT says it is a non-metal. Okay, so it contains non-metal like arsenic, antimony, silicon, germanium, tellurium, and it contains some metals. So P block consists of non-metals, metalloids and metals. This is also correct statement. Heaviest elements in P block are metallic in nature. Heavier elements, see students, thallium, lead, bismuth, polonium. These are the last elements which are heavier, more atomic number. They are metallic in nature. So because top to bottom metallic character increases due to increase in a size and decrease in ionization energy. So option D is the correct statement. All the options are correct. Let us see the second question. Which of the following is most abundant in the earth crust? Which is the most abundant in the earth crust? What are the elements of boron family? Boron, aluminium, gallium, indium, thallium. In all this, aluminium is the most abundant element. But if you see the earth crust, see here, if you see the earth crust, it is having, which element? First is oxygen. How much is the percentage? Around 45.5%. After that, we'll be getting silicon. So first priority is oxygen. After that, silicon. Next is aluminium. But this is a non-metal, this is a metalloid, this is a metal. If they ask the question most abundant metal, then the first priority is aluminium. If they ask most abundant, if oxygen also gives element, then oxygen you should tick. In these options, aluminium is the most abundant. Aluminium is the most abundant. And the relationship between the first, second and third ionization enthalpies of group 13 elements are. What is the ionization energies order? See students here. Ionization energy means the amount of energy which is required to remove an electron. You want to remove the electron, so how much energy you have to apply to remove that electron. So first time removing IE1, second time IE2, third time IE3. So in this IE1, IE2, IE3, see 801, 24, 27, 3659 increasing IE1, IE2, IE3 increasing. So this is a correct option. IE3 greater than IE2 greater than IE1. But here see this video fully I'll teach you all tricks and tips, okay, so that boron family becomes very easy for you. Watch up to the end. See here 801, 577, 579, 558, 589. It is not actually top to bottom size increases, ionization energy should decrease. But here the trend is not regular. IE1 trend is different. IE2 order you see, pause my video and see. IE3 pause the video and observe it. So you will be getting different trends. Okay, very difficult to remember. No, now let's see how easily you can remember. Actually, the expected order is boron. Here I'll write. See, boron, aluminium, gallium, indium, thallium. Actually, top to bottom, what should happen? Ionization energy should decrease. This should be the expected order, but this is not correct. This is not the correct order. So what is the correct order is IE1, IE2, IE3. Let's see students, IE1, IE2, IE3. IE1, IE2, IE3. Different trends. Simple, tip I will tell you as a time being. Actually, this thallium is in a 1, 2, 3, 4, 5. Thallium comes to second position. And aluminium, gallium, there is an exchange. Why it is so? Gallium, due to the presence of D10 orbitals, pore shielding we observe in gallium. And thallium, due to the presence of 4F electrons, it is pore shielding. So due to more pore shielding in thallium, it is having that nucleus holds the electron so tightly. So thallium is one of the exception. In this, thallium, this two thallium is having high. In this two, gallium is having high. This is one exception, this is one exception. But if you see the order, boron, last thallium comes to the which position? Second position. After that, gallium, aluminium, and then indium. You have seen two exceptions. These two positions interchanged, and thallium comes to the second position. Okay, two exception. Why so? In thallium, 4F is completely filled, and gallium 3D is completely filled. So nucleus hold, this is a pore screeners, nucleus holds electrons tightly. Regular class, lengthy video time I'll teach you. So size decreases, it is the holds tightly, it is difficult to remove the electron. Fine. Now see the technique students, IE3. What you do is boron, aluminium, gallium, indium, thallium. These two positions you interchange. That is IE3. Boron, next gallium, next thallium, next aluminium, indium. That's it. Next IE3, IE2 if you observe, not only these two positions also you interchange. Then boron, thallium, gallium, next indium, last one is aluminium. Actually our question is only this, but I covered total. Any ionization energy order you will do it. IE1, IE2, IE3. Is it clear? Next. Which of the following statements is false about chlorides of aluminium? It on hydrolysis, they are asking about AlCl3. AlCl3, it on hydrolysis in water forms tetrahedral species like this, AlOH4 minus, and it in acidified aqueous solution form octahedral species like this, and it achieves a stability by forming a dimer in vapor phase, and coordination number of aluminium in its crystalline form is 8. These are the 4 statements given. Here one important point I want to tell you. See here. These elements usually, boron family usually forms tetrahedral species like this. these chlorides upon hydrolysis in water, what we get? Like this we get MOH4 minus. In this, metal is surrounded by, or central atom is surrounded by 4 OHs are present. Like this, metal is, or element is surrounded by 4 OHs, 4 OHs. And what is the hybridization? Total steric number 1, 2, 3, 4 bonds are there. So its hybridization is sp3 hybridization. So here hybridization is how much? sp3. And AlCl3 in acidified aqueous, so it was formed by all elements, they form this boron, aluminium, remaining. So this is correct option. Acidified aqueous solution form octahedral. Yes. Aluminium chloride in acidified aqueous solution, what it forms? Octahedral species. So these two was formed by the aluminium, but boron is the only one element. It cannot form 6 ligands. It can't combine with the 6 ligands because boron electronic configuration is 2s2 2p1. It is not having any vacant d. Maximum how many electrons how many bonds it can form? Just 4 bonds. So this option is also correct option. It can combine aluminium AlCl3 in acidic medium, undergoes hydrolysis like AlH2O6 3+. Octahedral complex it will form. Correct option. It achieves the stability by forming a dimer in vapor phase. So how is the dimer? Dimer is like this. See the dimer? Aluminium AlCl3. Another AlCl3. Okay, this AlCl3, this is Al, Cl, Cl, here one Cl. This donate a pair of electron to it, this donate a pair of electron to it and forms Al2Cl6 dimer. So this is also correct answer. Next, coordination number of aluminium in its crystalline form is 8. This is wrong. Why it is wrong? Because maximum aluminium can form 6 bonds, not 8 bonds is not possible. So this is the incorrect false option. Option number 4 is correct. And what is the hybridization of aluminium in this complex? sp3d2 is the hybridization. Aluminium hybridization is sp3d2. Which of the following is true regarding gallium? Gallium, for example, say students, boron, aluminium, gallium, indium, thallium. Usually top to bottom, what happens to the boiling points and melting points? Super tip I want to tell you, that is melting and boiling points usually decreases top to bottom. Okay, there is no exception in the melting point. Order is top to bottom, boiling points decreases because boron is small size, more forces of attractions between them, then more is a boiling point. Fine. But coming to the melting point, there is an exception. Exception is just interchange 3,5. 3,5 interchange you do. 3,5 interchange. So this is boiling point, no exception. Coming to the melting point, what is an exception? 3,5 exchange. So boron and then aluminium, next one is indium, next one is thallium, last one is gallium. So gallium is the element which is having, unusually low melting point. How much is the melting point? 303 Kelvin. 303 Kelvin is the melting point. That is the reason, due to low melting point, it exists as a liquid state during the summer. It exists as a liquid, during the summer. And but if you observe, it is having high boiling point. How much? 2676. I am not telling highest in the entire P block. Entire P block highest element is boron, but in these three, which one? Gallium is having the, which one boiling point is high boiling point. Option D is all the statements are correct. See how easy. Now, the element which shows least metallic character: boron, aluminium, gallium, indium, thallium. top to bottom size increases. So easily we can remove the electron. Ionization energy decreases. So metallic character of the elements increases top to bottom. So which element is having least? Boron is having a least in the entire boron family. Let's see the next question. Which of the following does not form M3 plus ions? Which can't form? Actually boron family, how many electrons in the valency shell? Ns2 np1, 3 electrons in the valence shell. We can easily remove the usually 3 electrons. They should show plus 3, but the first element boron don't show plus 3. Why? Because of the small size. Due to the small size of boron, it will be having highest first 3 ionization. The sum of all the 3 ionization enthalpies are high. Due to the high ionization energy, due to small size, it is very difficult to remove the 3 electron. That is the reason B plus 3. Ion don't exist. If you see BCl3 in this boron is in plus 3 because each one, but it is in which compound? Which one? It is a covalent. They form plus 3. It don't form the plus 3 ions, but it likes to form only covalent compounds. Which compounds it form? Covalent compounds due to small size and more ionization enthalpies. Next, thallium shows different oxidation state. Why? Why thallium shows THA? Why thallium shows a higher different oxidation states? Because usually thallium family, boron family is boron, aluminium, gallium, indium, thallium. What is the valence shell configuration? This is 2s2 2p1. Next one is 3s2 3p1, 4s2 4p1, 5s2 5p1, 6s2 6p1. 5s2 5p1, 6s2 6p1. Last element, actually they have 3 electrons in the valence shell, though, so they should show plus 3 oxidation state. But top to bottom, the ability to show plus 3 oxidation state decreases. Plus 3 oxidation state decreases. Which oxidation state increases, students? Plus 1 oxidation state stability increases. So if you observe these 3 elements, gallium, indium, thallium, they even show plus 1 oxidation state. In that, thallium plus 1 is more stable. Thallium, if you take plus 3, it likes to convert immediately into plus 1 state, because the last 2 electrons in the, that 2 electrons which are present in the S don't involve in the bonding. The reluctance of S orbital, S electrons, or the non-participation of S electrons in a bonding, we call it as inert pair effect. Why so? Why thallium is showing inert pair effect? Because thallium comes next to the after filling of F, so that a pore screening effect of the F, nucleus holds that outer electrons, that S electrons, very tightly. It is difficult to remove those S electrons. That is the reason there's 2 electrons. See, I'm explaining like a revision, okay? I'm not explaining small for the first time. Learner like that, coming examination, boron family, to cover little speed I'm explaining. So thallium 3 plus thallium plus 1. Which one? Due to inert pair effect, it shows plus 1. If you observe here, it shows plus 3 and plus 1, both the oxidation state. Why it shows? Due to inert pair effect. And one more question I want to cover. Plus 3 plus 1. Plus 3 oxidation state is there, no? It gains the electrons faster and converts into plus 1. Gains electrons faster, convert into plus 1. So how many electrons it gains? 2 electrons. Means it is gaining electrons. It is undergoing reduction. It is undergoing reduction means the element which undergoes reduction acts as which is gaining, means from where it is gaining? From other element. So it is oxidizing other element. The one which is undergoing reduction is a good oxidizing agent. So here see, thallium it shows plus 1. Thallium it shows plus 1 oxidation state, and it shows a +3, both +1 and +3 oxidation state, whereas the +1 oxidation state progressively increases down the group. If you see down the group, it increases, and due to +1 stability oxidation state, immediately it gains the electrons and converts into +3, converts into +1. So it acts as a good oxidizing agent, oxidant. It acts as a oxidant. The metal that has very low melting point, which one? Which one is having low melting point? Gallium. And last it comes in the boron family, and it is position is closer to metalloid. Which element? Gallium. Very good, very good. Next question. Which one? Melting point least, you see in this. See the order, how irregular order it is. What you do? Boron, aluminium, gallium, indium, thallium. Tell me the tip, students. 3 and 5 positions, just interchange here. This is for melting points. Top to bottom it should decrease, but exception is 3, 5 interchange. Boiling points, no exception. Top to bottom decrease. See, decrease, 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 decrease. Top to bottom decreases. Aluminium vessels should not be washed with materials containing washing soda, because see, aluminium vessels, what will happen? Aluminium vessels, if you take aluminium vessel, if you treat first time when it comes in contact with water, immediately it reacts with water and forms aluminium hydroxide, which is a protective layer around the aluminium. This is a protective layer around the aluminium. But whenever you treat with a sodium carbonate, washing soda, what will happen? Washing soda, first when you are washing with this aluminium vessels, first it reacts with water and forms NaOH. Now this NaOH disturbs this protective layer. It combines with this protective layer and it forms NaAlOH4. This is called as an sodium tetrahydroxy aluminate 3. This complex is a soluble complex. What is this complex? It's a soluble complex. So, washing soda reacts with aluminium and it forms sodium and soluble sodium aluminate. So, option C is the correct statement. That is the reason we should not wash aluminium vessels with the washing soda. Which of the following does not react with the aqueous NaOH? Which one we should not react with aqueous NaOH? Which does not react? Boron. See here, boron does not react with acids and alkalis even at moderate temperature. Even at moderate temperature, due to small size, inertness, it don't reacts with acids as well as the bases. So option 1 is a correct answer. After this video, one time if you have a time, go through NCERT, you feel your NCERT becomes very easy for you. Which among the following oxides reacts with alkali B2O3, Al2O3 and Tl2O3? Here one point I want to tell you. See students towards the screen. Boron, aluminium, gallium, indium, thallium. And coming to their oxides, B2O3, Al2O3 and Ga2O3, In2O3, Tl2O, or Tl2O3 plus 3 is not stable, that's why we write Tl2O. Because in Tl2O3, thallium is in +3 oxidation state. It is stable in +1, that's why we write Tl2O. In all this, if you see, or you can, this is acidic. This is acidic. And this is amphoteric. And these are basic. So acidic, amphoteric and basic. Then what will happen? They are asking which one will react with the base. To react with the base, it should be acidic in nature. So which is acidic? B2O3 is acidic and these two are amphoteric. Amphoteric means which reacts with both acids as well as the bases. So Al2O3, which is reacting with that is amphoteric. It reacts with acids as well as a bases. So this is also amphoteric acid. It reacts with acids as well as a bases. So here you see Ga2O3 option not there. Only these two is there. So option 1 is the correct answer because acidic amphoteric. They reacts with both bases. Next. What is X in the following reaction? Just now we discussed. Aluminium reacts with the sodium hydroxide. First, aluminium reacts with the water and it forms AlOH thrice. Simple and easy reaction. Both, then it reacts with NaOH. Both reacts, forms Na plus Al. How many hydroxide ions, students? 4 hydroxide ions. So which is the correct option? Option 2 is the correct one. Sodium, what is its name? Tell me. Sodium tetrahydroxy aluminate 3. Why aluminate? Metal is in anionic complex. That's why we should end the metal with a 8. Aluminate, and oxidation state is +3. Next one. See, this is the reaction. Why I am showing? Because it becomes very easy for you. When you open a textbook, easily you can recollect. Sodium tetrahydroxy aluminate 3. Amphoteric oxide among the following. Which oxide is amphoteric? Boron, aluminium, gallium, indium, thallium. This oxide is acidic. These two oxides are basic. And last two is these two acid. This is acidic, amphoteric, basic. So these two is amphoteric. So they are asking amphoteric which one? Aluminium not there. So only gallium is there. Option B is the correct answer. Option B is the correct answer. See here. Boron trioxide is acidic and then it reacts with the basic oxide. If it is acidic, it reacts with the basic oxides and forms metal borates. Aluminium and gallium are oxides are amphoteric and indium and thallium are basic in their properties. Okay, students, the electronegativity of aluminium is similar to see here. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Here and next sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. Here one small point I want to tell you. Here this element is there, no? This first element shows similar properties with this element. This element shows similar properties with this element. Actually, this is 1A. This is 2A. 2A, first element of 2A shows similar properties with the second element of the third A group. Actually, same family, it should show the similar properties, but that's one element of that family shows similar properties with the element of the other family. So this nature is called as a diagonal relationship. What is this nature? Tell me. Diagonal relationship. So here, how much is the electronegativity? Let us see. One technique I will tell you to remember. Actually, here it is not needed, but it will help you. This is its electronegativity is 1 and its electronegativity is add 0.5 to this 1.5, add 0.5 2, this is add 0.5 2.5, add 0.5 3, add 0.5 3.5, add 0.5 4. Just from lithium you start, add 0.5 0.5 0.5 and you go. Easy. Next, let's see the next one. Start here 0.9, add 0.3 1.2, add 0.3 1.5, add 0.3 1.8, add 0.3 2.1. From here until you added 0.3. Now add 0.4 2.4. Add 0.4 I told, no, 2.5. Next add 0.5 3. So here the difference is 0.4. Here the difference is 0.5. Only for the last 3. This is the up to here 0.3, next 0.4, next 0.5. Now what I want to tell you, if you observe beryllium electronegativity, how much, students tell me? 1.5. Aluminium electronegativity, how much? 1.5. Both their electronegativities are same. So which two elements? Aluminium electronegativity electronegativity is similar to beryllium. So which is the correct option? Say loudly, which is the correct option? Beryllium is the correct option. See here, what is electronegativity of aluminium? 1.5. Even beryllium also 1.5. In this video, you learned entire second period and third period electronegativities. Which element shows +1 oxidation state? +1 oxidation, see here small question, it's missed. See, stability order of +1 oxidation state. Something happens. So stability order of +1 oxidation. What is the correct stability order? I told you top to bottom +3 stability decreases, +1 stability increases. So which three elements shows +1 more? Gallium, indium, thallium. In that thallium shows +1 more stable. So top to bottom, aluminium, gallium, indium, thallium, top to bottom stability of +1 oxidation state increases due to inert pair effect. So A is the correct answer. Most important video, you know, once if you finish the entire video, just put a 2x speed or try the answers fatafat. Okay, short time you can cover the maximum of the textbook topics. Which metal is protected by a layer of its own metal oxides? For example, aluminium is a metal. Why? Because aluminium when you treat with aluminium when you treat with concentrated HNO3 or when it undergo oxidation, aluminium, what it will form is, it forms Al2O3 layer, aluminium oxide. Actually this is the aluminium piece metal. This aluminium oxide forms a layer around this aluminium. So aluminium will be inside. This Al2O3 layer acts as a protective layer so that inside aluminium cannot react with the outer air further. So in such a way it forms a protective layer around itself. Which element forms like that? Aluminium forms this. See, concentrated nitric acid renders passive aluminium passive by formation of a protective oxide layer on its surface. When you add concentrated HNO3 to the aluminium, what it forms again? Al2O3. That forms a protective layer. Which of the following hydroxide is acidic? See this hydroxide, OHs are there means hydroxide. See this hydroxide. This is a metal hydroxide. Aluminium is a metal. Okay, calcium is a metal. Thallium is a metal. Boron is a non-metal. So, non-metal hydroxides are acidic in nature. Metal hydroxides are, tell me, these are basic in nature. That is the reason if you observe BOH thrice, if you put in water, what will happen is it absorbs. What it will absorb? It absorbs, one of the OH minus ion and it forms BOH4 minus and it releases H plus ions. From water, what it is absorbing? Water means H plus OH minus. This OH minus it accepts. This OH minus it accepts and it releases what, students? It releases H plus into the solution. Due to the H plus ions in the solution, these are acidic. It is BOH thrice, it accepts pair of electrons. A pair of lone pair acceptor is a Lewis acid and which releases H plus ion, that's why acidic. Okay, now let us see some most important, just for assertion reasoning, most important assertion reasoning we will see. There is a discontinuity observed in the ionization enthalpy values between aluminium and gallium, similarly indium and thallium. Correct, no? Why? Boron aluminium, what happens students? Tell me. Boron, aluminium, gallium, indium, thallium. Actually top to bottom should decrease ionization energy. But what is exception? Here is one exception, here is one exception, two exceptions. But if you see the overall order, first boron, next thallium will come. Why? Due to poor shielding effect of f orbitals. Next gallium will be having high. Why? Due to poor shielding effect of d orbitals. And then indium, and last is ionization energy is aluminium. That is the reason aluminium low ionization energy. It acts as a metallic in nature. Now see here, first boron to aluminium. Due to the, what is the reason? What is exception? Indium, thallium, one exception. Aluminium, gallium, one exception. Why it is so? Because of inability of D and F electrons. They can't act as a good screeners. They have very low screening effect. Due to this screening effect, low screening effect, nucleus holds that electrons tightly. That is the reason removing is difficult. So there is a discontinuity in ionization enthalpies between aluminium, gallium. Similarly, indium, thallium, correct option. Screening effect of D and F electrons are poor. That is also correct. D and F poor screening effects. Next, boron has unusually high melting point. Yes, top to bottom melting points and boiling points decreases. There is no exception in boiling points, but melting point, what is exception? Students tell me. 3, 5 you should interchange. So this is the correct statement. And boron, due to its small size, it is having very good forces of attractions between them. So strong crystalline lattice boron is having. Boron is having, see the melting point how much? 2453, and even it is having high boiling point also, 39, around 3900. So both assertion and reason are correct, and it is a correct explanation. Next question. Boron forms only covalent compounds. Boron forms only covalent compounds. Why boron forms only covalent compound? Due to small size and high ionization energy, it can't exist in a ionic form. That is the reason it forms a covalent compound. The sum of the first 3 ionization energies are very high due to small size. So due to small size and high ionization enthalpies, the first 3 ionization enthalpies are very high. Due to this reason, B3 plus ion does not like to exist. So what it will exist? It exists in a covalent, in this plus 3 is there. But this is which compound? Tell me. This is a covalent compound. It is forms only covalent compounds. So assertion and reason both are correct explanation. Boron is unable to form BF6 3-. Why? Because boron is not having any vacant D so that it can expand its covalency. No, boron is 1s2, 2s2, 2p1. Only 3 electrons in the valence shell plus 3 it can show. If it accepts a pair of electrons, so 2s2, 2p1. So in S contains 2 electrons, P is having only 1 electron. So if this excites from here to here, maximum it can share 3. If it accepts 1 lone pair, maximum bonds it can form 4. So it can't form 6 bonds. Wrong option. Boron is unable to expand its octet. Why? Due to the absence of d orbital. Boron is not having d orbital. So both assertion and reason are correct. One second. Reason is correct, assertion is wrong because it is not having d orbitals, that's why it is not showing. Okay, next one. Let us see some true or false statement questions. Most important, fatafat we will complete. The maximum oxidation state shown by p block elements is equal to the total number of valence electrons. How many valence electrons are there in a p block? Tell me. N is 2 Np1. So they can show how much plus 3 is the oxidation state they can show. Yes, true. Next, Keranite is a keranite formula. See, keranite is one of the source of boron. Its formula is Na2B4O7 Instead, here one more point also I will cover, students. Instead of 4H2O, if I put in this place 10H2O, then this formula becomes bauxite. Borax. What is the borax formula? Na2B4O7 10H2O. If 4H2O, that is called as keranite. If what is another source of boron? Borax. Boric acid. What is boric acid formula? H3BO3. So you came to know about boric acid, keranite and borax. Done. Now same way, let us see for aluminium also. Aluminium sources are bauxite is one of the source. What is the formula of bauxite? Al2O3 2H2O, and cryolite Na3Al(F6) is a formula of cryolite. And so this is also correct. True statement. Atomic number of radioactive element nihonium is 113. What is that? Nihonium is 113. See here. Nihonium. See down nihonium. What is atomic number? 113. Let us see here one small tip I want to tell you. Super tip it will be. Okay. Like, if you like this, please hit on like. Okay. See the tip. Boron, aluminium, gallium, indium, thallium. So here, what is atomic number boron? 5. 5 plus 8, 13. 13 plus 18, 31. 31 plus 18, 49. 49 plus 32. How much? 81. Thallium is 81. The next one is add 32, you get 113, that is nihonium. So what is that? 8, 18, 32. Listening students. Ma'am, this is common, no? 8, 18, 32. Then what is the logic, ma'am? What is the technique here? See the technique. If they give you 113 element belongs to which block in the periodic table also they can ask you. Okay. So 113 there, no? That last 13 you see. That 13, 1, 3. That 13 is then a 13, 1, 3. So boron family is also known as 13th group. Suppose if they ask you 114 belongs to which block in the periodic table? See the last one, 14th block. I mean 14, which group? 14th group. Carbon family is the 14th group. Next, for example, 115. See, this is 113, boron family, carbon family, nitrogen family. 116 is oxygen family. 170 last element is this. And noble gases is 118. Let them ask whatever. For example, they are asking 116 belongs to which family. Just remove the first number. See the last two numbers, 16th group. Directly mark your answer. You will be getting there easily your mark. So this is also true option. This is also true. Next. Atomic radius of gallium is less than that of the aluminium. Let us see. Boron, aluminium, gallium, indium, thallium. See now one video, previous video I have made best video from boron family. There I clearly explained what is the radius order. Okay, let us say in short. Boron, it's a 2s2 2p1. In aluminium electronic configuration valence shell is 3s2 3p1. Gallium is 4s2 4p1. Indium is 5s2 5p1. Thallium is 6s2 6p1. But if you see in this case, you know what happens, students? Gallium suddenly 3D comes, which is fully filled. Here as usual 4D10, because 3D once entered here 4D. Here suddenly 4F will be completely filled. Once this is completely filled, F here, F when it is completely filled, top to bottom, what should happens in the size? Size should size should increase like this expected. But once suddenly D comes, this is a D orbital, poor screeners, they can't act as a good screener. Outer electrons attract very easily. So gallium actually it should have larger radius, but gallium is having very small radius. Why? When compared to aluminum, why? Because of 3d electrons. If you see the trend here, see here, atomic radius 88, 143. Next should increase, but it decrease due to, this is an exception. Gallium comes to aluminum place, aluminum comes to gallium place. Fine. See here. Last is due to the presence of again sudden entry of F, actually size should increase, actually increasing, but the increase is very less because of F electrons. Size, it decrease. That is the reason, 167, next it should actually so much it should increase, but due to this poor shielding effect of F electrons, size will decrease and it remains as 170. In comparison, if you observe 170, it's an increasing order only, so there is no exception. So what is the correct order? Boron, and then next is gallium, next aluminum, indium, thallium. Then what is the order? Tell me. Boron is next, gallium, aluminum, thallium. This is the order. Which is having more radius? Thallium. Which is having, in this two, which is having less radius? Gallium. So gallium radius is less than aluminum. True option. Order of first ionization enthalpies of. Is this correct? No, we already discussed. What is the trend? Boron, aluminum, gallium, indium, thallium. Actually, top to bottom, IE should decrease. But what are the two exceptions? These two. What will happen if you arrange them in an order? Boron, thallium comes from last to second position. Gallium comes here. So what is the correct order? Boron, thallium, gallium, indium. Last one is which one? Aluminum. Ionization energy is low. Is it clear, students? Is it clear? Next. Let us see. What is it? Order: boron, thallium, gallium, aluminum, and then indium. Okay? And then indium. Correct. Before I told, change the position. See, boron, thallium, gallium, aluminum, and then indium. This is which one? IE1. If IE3 you want, these two you interchange. IE2 you want, these two you interchange, these two also you interchange, then you get IE3 also. Next, order of electronegativity. This is false statement. No? Order of electronegativity. What is electronegativity order? Listen carefully. Electronegativity order. See the electronegativity order, students, here. Boron is having how much is the electronegativity? 2. After that 1.5, 1.6, 1.7, 1.8, which means that first actually electronegativity top to bottom should decrease. But it decrease only up to aluminum. After that it increase. Boron, gallium, indium, thallium. This is an exception. So correct order if you observe, from year to year it increase. Aluminum. It's a correct trend if you observe. Actually up to here it decrease and then it increase. So what is the correct order? Thallium increasing. Okay. Next. In this pattern only I'll write. Thallium, then indium, next gallium, last is aluminum. But what I told you, gallium, boron is having highest. How much it is? It is more than thallium. This is a boron. Boron comes to first position. So first is boron, aluminum, gallium, indium, thallium. Reverse the order. So last fifth one comes to the second position. So boron, next thallium, next element indium, next element aluminum, like that. So the least one which is having low electronegativity is which one? Aluminum. So boron, and then this order is wrong order because thallium is having the highest. then this is false statement. Gallium has unusually low melting point. Yes, correct. How much is the melting point? That value should fix in your mind. 303 Kelvin. 303 Kelvin. So this is true statement. Stability of +1 oxidation states. What happens, students? True or false? Tell me answer. True or false? Correct? No? Correct? If you get the correct answer, put it in, give one like please. Indium oxide is amphoteric in nature. Indium oxide is amphoteric or not? No. Boron oxides are acidic. Aluminium gallium oxides are amphoteric. Indium thallium oxides are basic. So this is a false statement. Concentrated nitric acid renders aluminium passive by forming an oxide layer on the surface. Correct or not? Aluminium, when you treat concentrated HNO3, what it forms? Aluminium oxide, one layer. This layer protects this aluminium so that aluminium can't react further with the atmospheric oxygen. So this is a true statement. That's it. Your boron family, becomes very easy for you. Now once if you want to read, just go through your NCERT. You feel very happy and just listen this, put it to X speed, do all questions one time. Then I hope this video is helpful for you. My name is Komali. I am your chemistry mentor. Thank you so much for watching this video. If you want more best videos like this, please subscribe my channel and just hit on that bell symbol. Then only you will get more whenever I put a video, you get the notification. And I am taking online classes too. If you want to learn this syllabus in a detailed manner, slowly, from basics to the depth of each and every concept, what is atomic radius, ionization, enthalpy, how it changes step by step. If you want to learn, basics to even depth of the syllabus for clearing your NEET examination and JEE Mains examination, you can WhatsApp me. You can join into my online classes and you can get excellent score in chemistry. Thank you so much for watching this video. Bye, all of you. See you again in next video. Have a nice day.